Today, we're going to talk about how shapes move. And believe it or not, this is something you deal with every single day. I mean, from flipping a pancake to just sliding your phone across a table, geometry is literally all around us. Seriously, think about it. Every time you check your reflection, push a book out of the way or turn a steering wheel, you're actually doing a geometric transformation. It's math in action, and today we're going to break down exactly how it works.
So, we're going to tackle the three main ways that shapes and objects change position in geometry. And I promise, by the end of this, you'll be able to look at a shape and know exactly where it's going to land after it flips, slides, or turns. All right, first up, let's talk about reflections. If you can just picture a mirror, you're already halfway there. It's that simple. So what is a reflection? Well, at its core, it just creates an identical copy of a shape, but flipped over. That imaginary mirror is what we call the line of reflection. And every single point on the shape is the exact same distance from that line as its copy. Let's start with reflecting across the x-axis. You know, that horizontal line. When a point flips over this line, its left to right position doesn't change at all, so the x-coordinate stays the same. But its up and down position inverts, so the y-coordinate just flips its sign. And you can see that happening right here. The point x, y travels straight down, perfectly vertical, across that x-axis and lands at x, y. Same horizontal spot, but the complete opposite vertical position. Now, what if we reflect across the y-axis, the vertical line? Well, the logic just reverses. This time, the shape's height doesn't change one bit, so the y-coordinate stays put, while the x-coordinate is the one that flips its sign. And here we see it. The shape just hops sideways across the y-axis. Its height is totally unchanged, but its horizontal position becomes the perfect mirror opposite of where it started. Okay, moving on to our second move. Translations. Now, this might sound kind of fancy, but it's really just a simple slide. That's it. With a translation, the entire shape moves together as one solid piece. It's not rotating, it's not flipping, it's not changing size. Every single point on that shape shifts the exact same distance in the exact same direction. And here's the math that describes that slide. The A value tells us how far to move left or right, and the B value tells us how far up or down. So a positive A means go right, a negative A means go left, a positive B goes up, and a negative B goes down. Simple as that. This visual really helps break it down. That horizontal journey is A, and the vertical journey is B. When you put them together, they move the original point A to its brand new spot, which we call A prime, just to show it's the new transformed point. All right, we've flipped and we've slid. For our final move, let's get ready for the big one, rotations. So with a rotation, we're basically pivoting a shape around one single fixed spot. It's exactly like the hands of a clock moving around the center. Every point in our shape turns around this anchor, which we call the center of rotation. Okay, listen up, because direction is everything in rotations. By convention, in math, moving counterclockwise, that's the opposite way a clock's hands move, is considered a positive rotation. Moving clockwise, like a normal clock, is a negative rotation. You've got to remember that one. Let's look at the three most common rotation rules you'll see, especially when we're turning around the origin. For a 90-degree positive turn, or counterclockwise, the original coordinates x, y actually swap places, and the new x value becomes negative. For a 180-degree turn, it's easy. Both signs just flip. And for 270 degrees, they swap again, but this time the new y value becomes negative. This diagram really brings that 90-degree rule to life. Just look at how the original point xy swings up and to the left, landing perfectly at its new coordinates of negative yx. See? It's a very precise, predictable turn. Phew! Okay, I know that was a lot of information. So let's lock it all in with a quick summary, and then it's time to put your new skills to the test. So let's boil it all down. Reflection, that's a flip. Translation, a slide. And rotation, a turn. Each one moves a shape in its own unique way, but they all follow these precise, predictable rules. All right, ready for your first challenge? Let's start with a reflection. Remember the rule for flipping something across the x-axis. Which number changes and how does it change? Next up, a translation. We're going to slide the point to -1. All you have to do is apply those moves to the x and y coordinates. And for our last one, a rotation. Think back to that rule for a positive 90-degree turn. What happens to the coordinates? All right, Now's your chance. Go ahead and hit pause, maybe scribble these down on a piece of paper, and work through them. Don't worry, we'll be right here when you get back.
Okay, you ready? Let's check those answers. For the reflection of -1, 3, the y-coordinate flips, giving you -1, -3. For the translation of 2, -1, you add 3 to the x and 4 to the y for a new point of 5, 3. And for that 90-degree rotation of -4, 2, the coordinates swap and the new x becomes negative, landing you at -2, -4. Awesome work.
And just like that, you now get the 3 fundamental ways that shapes move in geometry. Seriously, the more you practice with reflections, translations, and rotations, the more all of this will become second nature. Thanks for diving in with us.